When we talked about the order of operations, we established a procedure for how we complete problems, arithmetic problems. And if we look at something like A times the quantity B plus C, using the order of operations, we would first have to figure out what B plus C is because that's inside a set of parentheses. We would evaluate that and then multiply that result by A. The distributive property, though, gives us a way to rewrite the problem, similar to what we did with the commutative property, but in a way that may not be as intuitive. What the distributive property tells us is that if we have a number times some expression in parentheses where we have terms being added and subtracted from each other, we can take that number out front and we can distribute it through each of those terms, meaning we're going to take A and multiply it by every term inside those parentheses. So this will become, or this is exactly the same thing as A times B plus A times C. Now what we've done is created a new problem which would start off with two multiplication steps, A times B and A times C, and then the last step would be adding those results together. So we still follow the order of operations, but if we apply the distributive property first, we can rewrite or modify that problem without changing the value of the expression. If we have something similar, but we have A times the quantity B minus C, the distributive property still tells us that we can take that value A and distribute it through, multiply it by each of those values. So in this case, we would end up with A times B minus A times C. So whether we have a plus or a minus, the sign of those numbers just remains. And similarly, we can do this if the expression in parentheses comes first, because we have what's referred to as the commutative property of multiplication, which is very similar to the commutative property of addition. It tells us that A times B is equal to B times A. So it doesn't matter what order we have this originally written in. We can rewrite this as A times B plus C, or we can rewrite this as A times B minus C, meaning we would end up with exactly the same expression, A times B plus A times C, or A times B minus A times C. So it doesn't matter whether the expression in parentheses comes first or second. If we have a number multiplied by some quantity in parentheses, we can distribute that through. In example 3, we'll take a look at this. In part A, we have 4 times the quantity B plus 1, meaning we'll take 4 times each of those values to give us 4 times B plus 4 times 1, or 4b plus 4. Those two expressions are exactly equal to each other. Similarly, in part B, we would come up with 6 times z plus 6 times 8, which would be equal to 6z plus 48. In part C, we have a slightly different situation. Rather than having a number out front, we just have a negative sign. But that negative sign is really just the value -1. But simplified a little bit, we don't write the -1, we just put that negative out in front, times x plus 5. So we would still take that -1 and distribute it through. This would become -1 times x plus -1 times 5, which would give us -x minus 5. Similarly, in part D, we would have -1 times x minus -1 times 5. But now what would happen is, since we have that subtraction in the middle, the two negatives would cancel each other out, leaving us with negative x plus 5.